Okay, so we have our second example. This one is based on the determinant now. Solve x minus 1 x and x plus 2 is equal to 0, 1, 2, 1, 1 x 2. So when you see these lines, it's another way of saying that the determinant of this. So being told that the determinant of this matrix inside here is 0. So solve for x. So you can choose any row or any column. We're going to have, and then you complete the determinant, then equate it to 0 if you get some variables mixed with. So in this case, let's choose the first column. The first column, the first entry is x minus 1 multiplied by, you cut here, cut there. So you get 2 by 2, which is 4, minus 1 by x, which is x, minus 1 minus 1, cut here, you have 2 by x, which is 2x, minus x plus 2 by x. So x plus 2. And then plus 1, cut here, cut here. So you have x, we have x minus 2, x plus 2. Equate everything to 0. Because this is the determinant equation. In the determinant is 0, so equate the determinant equation to 0. And we expand. So x by 4, we get 4x. X by x, we get negative x squared minus 4 plus x. And then minus 2x plus x squared plus 2x. So I'm multiplying this negative here, this negative by this negative, to have the plus, and then x by x, x squared, x by 2, 2x. And then plus x minus 2x minus 4 is equal to 0. Let's see which ones are canceling out. This 2x and this minus 2x. And then this x and this x cancels with this negative 2x. And then this x squared and this x squared will cancel. So we're going to have 4x. Negative 4 minus 4 give us negative 8 is equal to 0. Divide by 4. Divide by 4. We have x minus 2 is equal to 0. So that x is equal to 2. So we have found the value of x. And then another example. Show that show that one, to show that two, show that three, 1, 2, 1, -1, 2, 0 is not invertible. So let's check. So let's see. The first example, meaning example 2. Okay, so here the idea is knowing how to get the determinant. So we chose column 1. Where you pick x minus 1, and then cut here, cut this. What remains compute the determinant. So you have 4 minus x. And then from there, you go the second row, you cut this row, cut this guy as you pick -1 from there, and then compute the determinant for the remaining numbers. 2 by x, you get 2x minus x multiplied by x minus 2, I mean x plus 2. Then from there, you put the third number, cut, but get the 1. Then the remaining one, you have x minus, I mean x times 1, you get x minus 2 multiplied by this guy. Then the whole equation that you get, you equate it to 0 because we are told that the determinant is 0. That's what these lines mean. The determinant here is equal to 0. So when you expand this, you see some parts will be canceling. Just remaining 4x minus 8. You can take 8 the other side, or you can divide by 4 and then take to the other side. Now let's see how this is not invertible. If it is not invertible, so show that A is not invertible. So let's see. You get determinant A. If the determinant of A comes out to be 0, then it's not invertible. So let's pick row 1. So we have 3. You cancel here, you get 2 by 0, that is 0, minus 2. So 0 minus 2, and then minus 3. You cancel here, you have 1 by 0, which is 0, minus 0 minus 1, and then plus 3. Cut here, you get 1 by 2, that is 2, minus 2, minus 2. This is equal to 3 by -2, that is -6. And then -3 by +1, that is -3. And then 2 minus, that is 2 plus 2. By 3, that is 4. So altogether we have -9 plus 12, which is equal to 3. So you say hence A is invertible. Since the determinant A is equal to 3, which is not equal to 0. So once you're able to show that the inverse and the determinant is not 0, then you have shown that the function is actually invertible. So the issue of show that it's not invertible does not hold here because the determinant, the matrix is invertible. Determinant is non-zero. So do we have any questions? By the way, matrices are done. That must be good news. So if you see matrices, then it means that you're revising. It means the determinant is equal to 0. Okay. So I'm looking for some questions now that are based on application of vectors. Example 5. Find the area of the triangle with coordinate points A 1, -1, 3, B -2, -5, 4, and C 3, 1, -4. So you say, okay, solution. To find the area of this triangle, you first form vectors in between the points of this triangle, because what we have are points. So we need vectors. Okay. So you can form AB vector AB, and then we can form vector BC, and then we can form vector AC. So let's see what is AB. Vector AB is equal to, you start from B, subtracting A. So we have -2 minus 1, -5 minus 1, 4 minus 3, giving us -3, -4, 1. And then vector BC. So you first pick the coordinate of the inner point. So BC, you start with C, you pick 3, minus, go to B, pick -2, comma, go to the y coordinate 1, minus, go to the y coordinate in B, -5, comma, go to -4, minus 4. And then now you work them out. 3 minus -2, that's 5. 1 minus -5, that's 6. -4 minus 4, that's -8. Then you come to AC. AC again, CA. So you get 3 minus 1, is 3 minus first coordinate there. Then 1 minus -1, and then -4 minus 3, giving us 2, 2, -7. So these are the vectors. And now we must find the area of this triangle. So what we do is we get the area of a parallelogram. The parallelogram is in this form. Suppose we say this is A and this is B. Okay, so form a matrix here, and we'll get a vector here, A, B. Then we put C somewhere here. So we got vector AC, this vector here. So it means that we use AB and AC, assuming that BC is some vector here. Now we'll find the area of the parallelogram given by, because if you are in the parallelogram, then you assume that this 2 is B. So the distances between AB and CB should be equal. So if this is U, this 2 is U. This is V, this 2 is V. So you find the area of a parallelogram. So just pick two vectors. That is vector AB. So we pick AB. So say vector AB, do the cross AC. Cross AC. So you pick the base, and then this is equal to the determinant of I, J, K, and then you pick AB. AB is -3, -4, 1. Then pick AC. AC is 2, 2, -7, and get the determinant of this matrix, which is going to be, you pick the first row, you have I, and then you're canceling this guy, canceling this guy to get the determinant. So you have -4 by -7, that's 28, minus 2, and then minus j. You cut here, so you have negative 3 by negative 7, that's 21, minus 2, and then plus k, cut here, that's negative 6, minus 8, so plus 8, giving us 26i plus 19 minus 19j. The minus that's coming from what side? So minus 19j and then plus 2k. Then now, suppose this vector is v. I mean, how do you call v the cross product? So now you get the absolute value of this guy. You get the modulus of this vector cross AC. Get the magnitude, which is the square root of 26 squared plus negative 19 squared plus 2 squared, which is equal to 26 squared, that's 676, plus 19 squared, that's 361, plus 4. And then this guy, you add 676, we are getting the square root of 1041. So what's the square root of this guy? It's 32 point something. So what you do is, because it's not a whole number and you have no calculator, then you say, therefore the area of the triangle is going to be root 1041 divided by 2 units squared. Why do we divide by 2? Because a parallelogram, when you break it into 2 equal pieces, you get equal triangles. So whenever you're asked to find the area of a triangle, you go for the area of the parallelogram and then divide that area by 2. To get the area of this parallelogram, you get the cross product. The cross product is just the determinant of the 3 by 3 matrix, whose first row is ijk, the component of the vector. Then another one, find the example 6. You just choose 2. So if you want, you can make the choice of A, B, and BC and leave the other one. So it does not mean that you must use all the vectors. You just use 2 vectors, because the other vector is going to be the inner vector. So depending on your choice, you just need 2. You'll still give the same error. Then find the volume of the parallelepiped with position vectors A, B, C. That is A is equal to 1, 2, 3. B is equal to 3, 0, 6. C is equal to 7, 1, 9. So this is a parallelepiped, and then you want to get its volume, and you are given the position vector. So you first find the direction vectors. So you find A, B. You get 3 minus 1, 0 minus 2, 6 minus 3, which is 2, negative 2, 3. Then you find AC, that is 7 minus 1, 1 minus 2, 9 minus 3, giving us 6, negative 1, 6. Then you get BC. BC, that is 7 minus 3, 1 minus 0, 9 minus 6. So we have 4, 1, 3. Now for this one, to get the volume, you get all the vectors 2, negative 2, 3, 6, negative 1, 6, 4, 1, 3, and still get the determinant. If you pick the first row, you have 2, cut here, so get negative 3 minus 6, and then minus negative 2, cut here, you get 18 minus 24. When you multiply inside, so you have 18 minus 24, and then plus 3, cut here. The remaining matrix is a 2 by 2, whose determinant is well known. 6 by 1, you get 6 minus 4. So we have 2 by negative 9 plus 2 by negative 6 plus 3 by 10, which is negative 18 minus 12 plus 30. Yeah, so this is 0. You understand what structure is this whose volume is 0. Wow, interesting. So here's the 0 volume of this structure. Then there's another nice example.
With the previous board.
Sir, bring back this.
That one was invertible, sir.
Not invertible if the determinant is 0. How do you invert a 0 determinant? Okay, example 7. Show that so that the 4.6 negative 70, 16 negative 19 negative 4, 0 3 negative 6 and 2 negative 5 10 lie on a same plane, so that these guys lie on the same plane. So we have 4 points. Suppose we name them A, B, C, D. So we just need to have a cross product of n of the 3 points. If we get it to be 0, then they lie on the same plane. If it's non-zero, then they don't lie on the same plane. So for us to do that, we need vector AB, which is 16 minus 6, we get 10. Negative 19 minus 7, we get negative 12. Then negative 4 minus 0, we get negative 4. Then we need BC. So BC, 0 minus 16, get minus 16. 3 minus 19, we get positive 22. Negative 3 minus 4, get negative 2. They don't have CD. CD is giving us 2 minus 0, that's 2. Negative 5 minus 3, that's negative 8. And 10 minus 6, that's positive 16. Well, we could get AD, but it's all right. We already have 3 vectors. So let's get the cross product. 10, negative 12, negative 4, negative 16, 22, negative 2, 2, negative 8, 16. What's the determinant? We pick 10, you cut here, you cut here. You have 22 by 16 minus negative 2 by negative 8, and then minus 12. You cut here, you cut here. You have 16 by negative 16. That is negative 16 by 16 minus negative 2 by 2. That's negative 4. And then minus 4. So this becomes plus, because it's in the middle rather than invisible negative. And then negative 4. You cut here, you cut here. You get negative 16 by 8. By negative 8, so we just get 16 by 8. And then minus 22 by 2, that is 44. So what we have 10 by 22, 22 by 16. That is 352 minus 16. That's 336. And then we have 16 by 16. That's 256 negative. And then 4. So that's negative 252 by 12. That's negative 3024. And then minus 16 by 8. That's 128 minus 44. That's 84 by 4. That's negative 336. And then we have by 10 here, that's 3360. So 3360 minus 30024 minus 336. So we get 0. So if we get 0, then these points lie on the same plane. So we just form N3 points connecting these guys. So make sure that you have a line that connects all the points. Then you're getting vectors in between there. And then compute the cross product. If the cross product is 0, which is the determinant, if the determinant is 0, then you get the conclusion that these points lie on the same plane. And this is how we end the application of vectors and the application of matrices. So what remains is to be done in the revisions, starting very, very soon. Because tomorrow we are starting probability and statistics for those who are doing 1120. And then for 1100, I need to check which direction we should go.
So sir, for 11 what? 1100 won't have a class tomorrow.
I said that I need to check the direction that we need to go. So the checking will be done in the night and the class will be there tomorrow, but it won't be at the same time. So 1120 will take the 18 hours class. Then 1100
All right,
it will be communicated.
Sir, about the application of integration.
No, we're still coming back to that one, don't worry.
All right.
So for now, I can say good night.
No, sir. Sorry. Vector AB, that one. The vector is not multiplying. Why are we deducting?